Hi, my name is Jennifer Cowden and I'm a consultant here with ProModel. Today I'm going to be talking about a simulation project that we finished up a few months ago for a customer out in California. This particular company owns and operates several medical clinics in the LA area. And as you can imagine, the real estate in LA is pretty expensive. So this company they're trying to determine when is the best time to either expand one of their existing clinics or buy a new building altogether. We were contracted by the Vice President of Facilities Procurement. She had initially had a group of architects perform a study on two of her more constrained clinics, and she wanted to back that up with a simulation to look more into the interdependencies and the randomness associated with the staffing. So she had us model, to begin with, 9 of her more constrained facilities and 2 additional future clinic designs. She gave us timestamps for actual patient visits per clinic per month, and we used those as inputs into the model. Let me bring that up and start that running. This is one of her clinics. This is a floor plan that was put in to scale, so that we could capture nurse and doctor travel times. As you can see, we're running this one for the month of July. And right now we're at about 9:30 on a Monday morning. So we used as inputs into the model all of the independent timestamps, such as when the patient actually arrives, how long the doctor is with the patient in the exam room, how long it takes the nurse to take all the vital signs. What we didn't know were the doctor and nurse break times and any times that they're spent working but not necessarily with the patient. So we tuned those so that the output of the model, or the dependent variables, so to speak, such as the amount of time you have a patient waiting in the waiting room, the amount of time the patient is waiting in the exam room for the doctor to come, those were all considered outputs from the model. So we calibrated the model by looking at the overall time that the patient is in the system per the model and comparing that with the actual data that was given to us by the customer. And we were able to get that within 98%. So once the model was validated and tuned, we then used it to conduct several scenarios, such as future growth studies. So we would add patients in increments of 10%, and we were able to generate a graph for each clinic that looked something like this. The bottommost point is the actual patient load for a particular month. And this graph is for one of the more constrained clinics, or the clinic was claiming that it was constrained. But as you can see, we were able to increase the patient load by about 600 patients for that month before the patient time in system drastically increased due to running out of exam rooms. So in addition to the future growth studies, we were also able to model different process or policy changes. So that gave our customer the ammunition she needed to go back to her clinics and say, okay, if you make these changes, we do not need to invest in a clinic expansion at this time, or we do not need to purchase another building for you at the moment. So she was very happy because she was able to save her company a lot of money by running these scenarios and looking at these graphs. We consider this a very successful project, and if you've got any questions, please contact us here at ProModel, or you can contact me directly, jcowden@promodel.com. Thank you.